Hello everyone. Welcome to the another lecture of alcohol, phenols and ethers. Myself Suman Singh. So in the last class we were discussing about the preparation of alcohol, right, from Grignard reagent. So what we have seen when we are using the O2 at that time we have got ROH that one we have seen, right. So now we will see in detail today what to, because in the last class we have seen the overview of from the how we have to prepare this alcohol from Grignard reagent, right. So today we will see in detail. So before that, let me tell you, we will do one question. So in this question what it is written, which is the end product of the following reaction. We have to find out the end product, okay. So this is the question is given here. Question is given here. Now in this question, when you are seeing there, here is fluorine is there, here bromine is there, okay. And here what we are using, Mg or ether, okay. So at that time always remember that this Mg will first react with iodine, after that bromine, then chlorine, and then fluorine, okay. So where this Mg will attack, this Mg will attack to this bromine, not fluorine, okay. So when it will attack to this fluorine, at that time what we will get this, right. We will get this MgBr. Now next, in presence of SCHO, what will happen, it will form what, it will form this OMgBr, right. Now again, in presence of H2O and H positive, when we will hydrolyze this, what will happen here, this H positive will from this water will come and attack to this, and this MgBr or MgBr will come out from the reaction, and when we will get the final product as this, okay. So as you can see, so when we talk about the preparation of alcohol from Grignard reagent, there are two processes. One is what, reaction with aldehyde ketones and ether, and another one is reaction with ethylene oxide or oxidine. Okay. So one by one we will see this. In the first case, when we discuss about the reaction with aldehyde ketones and ester, what we can say, this Grignard reagent are alkyl or aryl magnesium halide, okay, as we know that, right. And the carbon magnesium bond, when we see this carbon magnesium bond in the Grignard reagent is that is, it is like this, right. R Mg, suppose here is X, so this one will be slightly positive, this one will be slightly negative, okay. Now is highly polar because the carbon is electronegative, right, which has electronegativity of 5, suppose 2.5, right, relative to the electro negativity or electropositive magnesium, who has an electronegativity of around 1.2 something, right. So this one, since the carbon which is attached here has a higher electronegativity, so that is why this bond which will form between them will be highly polar, okay. So due to this polar nature of this C and Mg bond, due to the polar nature of this carbon and magnesium bond, what will happen? This Grignard reagent, because of this, Grignard reagent are very versatile reagent in organic synthesis. Okay. So now when we talk about this Grignard reagent, it react with aldehyde, ketones, and esters, sorry, to form what, additional product. Okay, it will form first additional product which will be further hydrolyzed with either HCl or H2SO4 to give alcohol. Okay, we will see this. So now you see in the first case what is happening here. Suppose here what we have used here, suppose aldehyde, ketones, or anything. So as you know that this carbon has an electronegative this carbon and this, when we talk about this oxygen, the electronegativity of oxygen is more, right. So what will happen here in this case, this oxygen will take a slightly positive negative charge, and this carbon will take a slightly negative charge, right, a positive charge, right, as you can see. Now again, when we talk about this Grignard reagent, at that time, as we have already discussed, Mg has a slight electronegativity of 1.2, and carbon has 2.5. So here this carbon or whatever the group which is attached here, it will gain a slightly what, negative charge, right, as you see here, and this will gain a slightly positive charge. So now as we all know that positive will go in negative side and negative will go to positive side, so this R will go and attack to this, okay, and this Mg X will go and attack to this, right. So next product will be like this, as you can see, carbon, that carbon R has came here, it can attach to carbon, and with this oxygen Mgx has attached. Now again what we will do, we will hydrolyze this is a very simple, right. And when we will hydrolyze this with H2O, At that time, what will happen? This hydrogen will attack to this oxygen, and this Mgx will come out from the reaction. As you can see, this is the end product. MgOH will come out from the reaction. Okay, so this is what, this is an hydroxy magnesium halide. Okay, so I hope you have understood this, the reaction with aldehyde, ketones and ether. Now next is by the reaction with ethylene oxide or oxidine. So when we talk about the reaction with ethylene oxide or oxidine, always remember that epoxy alkene such as oxidine or ethylene oxide react with Grignard reagent in presence of you can take anhydrous ether, okay, to form what, additional product. It will also form an additional product which will further we will when we will hydrolyze this, by water in presence of some acids, it will give alcohol. Okay, as you can see this. So in here you can see ethylene oxide we have taken, and we have react with this CS3 MgBr. So what we have got? We have got the additional product first, as you can see here, CS3 CS2 CS2 MgBr, and when we further hydrolyze this, we have got alcohol, as you can see here, right? So how it has happened, we will see the mechanism. So when we see the mechanism, we know that here this one will be slightly negative and this one is slightly positive, right? And for this, since this oxygen is more electronegative, so it will take the electrons here, there will be a shift of electrons, so it will take a slightly negative charge, and this carbon will take slightly positive charge, right? So what will happen, this negative will attack to this and this positive will attack to this, right? So again you can see the additional product here. We have got the additional product here, right? And this additional product, when we will further hydrolyze, so at that time H positive will come to and attach to this oxygen, and this Mgx will react with OH and it will form MgOH. Okay, and here we will get the alcohol, which is this. So I hope you have understood this, right? Now next is very important topic, which is by reduction of carbonyl compound. So when we talk about by the reduction of carbonyl compound, it is either by the catalytic hydrogenation of aldehyde or ketone. Okay, and the next one is reduction using LiAlH4 or by NaBH4. Okay, we will see one by one. So first is what, reduction by carbonyl compound, reduction of carbonyl compound. So when you see that when the carbonyl compound will reduce, it will form either aldehyde or it will form either ketone. Okay, so as you can, first of all we will see, so this is our carbonyl compound. As you can see, in presence of NiPd, it will form CHOH. Okay, this is what, this is ketone, right? So it will form here CHOH. Okay, so as you can see, there is the ketone. In presence of NiPd, it will form CHOH. Now again, when we are taking aldehyde, at that time it will form CrCH2OH. Okay, 1 degree alcohol. And when we are taking here ethers, as you can see, at that time it will form this. This is chiral, right? This carbon is chiral because 4 different groups are attached here, right? So here it is, at that time it will form racemic mixture like this. So from this method, by the what we have seen, by the reduction with by catalytic hydrogenation of aldehyde and ketone, from this method we can make from this method we can make either 1 degree or 2 degree, but not 3 degree. We cannot make from this method we cannot make 3 degree alcohol or tertiary alcohol. We cannot make tertiary alcohol by this method. Okay, now next is some of the example is given here, as you can see. So it will reduce either this aldehyde, or it can reduce ketone also, right? So here you can see ketone is there, so it has been reduced to alcohol. In the same way here ketone, it has been reduced to alcohol. Here again this, it has been reduced to this alcohol. It is reduced, it can reduce double bond too. Okay, but always remember that it will not reduce yes, it will reduce double bond also. As you can see here, it is reducing, right? Here since double bond was there, here double bond was there, it is reducing, right? This one double bond is also get reduced. In this case also you can see double bond has been reduced here, right? So this is the some of the examples. Now next is by using LiAlH4. So this LiAlH4, when we are using this one, is it can reduce as you can see, it is already written. I have written this. It can reduce esters, acid, cyanide, COCl, CONH2, or carbon-carbon double bond. Now always remember that LiAlH4, it can reduce triple bond to double bond, okay, but not double bond. Always remember this, okay. LiAlH4 will reduce triple bond into double bond, but double bond into single bond it will not do, okay. It can do either triple bond to double bond, but not double bond to single bond, okay. So these are some of the things which he will reduce. It can reduce ether, acids, cyanides, COCl, CO, like this, okay. So one example is given there, as you can see, ketone is there, right? So it is reducing into OH, as you can see here. O first of all, and further hydrolyze we will get OH. So some of the example is given, as you can see, LiRH4. So it is reducing this. Here also it is reducing this COH. It is reducing aldehyde into alcohol. Again it is reducing ketone into alcohol. Here you can see it is reducing double bond into single bond, okay, when we are taking H2 or Ni. But when we are taking LiAlH4, it is not reducing this double bond, as I have already told you, right? It is not reducing double bond. But when we are taking here H2 or Ni, at that time it is reducing the double bond. But when we are taking LiAlH4, it is not reducing the double bond, right? As you can see here. Some more example is there, as you can see. This one is ketone. This one is aldehyde group. This one is ethers group, okay. So when we see this, when we will see this, at that time what will it can reduce this, right? And this can also reduce this, and he can also reduce this, right? So at that time what will happen, you can see it is reducing this ketone also, it is reducing this ether also, it is reducing this aldehyde also, and it is reducing this also, right? So it will reduce both, because as I have already told you here what are the things which it will reduce, right? So as you can see here. Now next is by NaBH4. So always remember that NaBH4 will not reduce acid and ether, okay, ester, but it will reduce aldehyde and ketone, okay. So as you can see, first example, RCOH, and in presence of NaBH4 it will give RCH2OH. Again this, in presence of this it will give RCHOHR, okay. Now again one example is given, very nice example is given here, as you can see what I have already told you. It cannot reduce what? It will not reduce acid or ester, okay. As you can see, this one is ketone here, ketone aldehyde, right, and this one is ester, right? So it is not reducing, you see in the product it is not reducing ester, okay. It is reducing ketone and aldehyde, but it is not reducing ester, as you can see here, right? Now next is by Bovial vent blank reaction, okay. Bovial vent blank reactions. So when we talk about this, here the reagent is what? Here reagent is this Na+C2H5OH. This is the reagent here, okay. So this reagent, when it will react, it will form 2H, and this H is called nascent hydrogen, right? We know this, right? In class 11 also you have learned this. 2Na plus C2H5OH, it will give what? Nascent hydrogen, which is 2H. So it reduces both ketone, okay, as you can see it is reducing this into alcohol, right? Again it is reducing this COOH into alcohol, COCl2 into alcohol, ester into alcohol, and ROH into alcohol, as you can see here, okay. So some of the example is given here, as you can see. In presence of this Na and C2H5OH, it will form alcohol. Now again in place of this alcohol, always remember that the OH hydrogen is coming from here, okay, from here, okay. Always remember that, because when we are using this, as you can see, when we are using, hydrogen is coming from here, okay. This hydrogen is coming from here. If we are using this Na and C2H5OH deuterium at the time, when we are using, at that time here there will be D, and this D will come from here. Always remember this, okay. Now next is this one, it will form OH here, right? So this is also easy, right? So if you are asked to find the product, what will be the product of the following reagent, so you can only find, right? It can reduce if NaBH4 when we are using, and in place of CH2OH, so it will not, as you can see, it will not reduce what, esters and acid, right? Acid and ester it will not reduce. So here, as you can clearly see, this one is what, aldehyde, this one is what, esters, right? So it is not reducing ester, as you can see, same as it is, right? But it is reducing aldehyde, right? Here again, this one is aldehyde, this one is ketone, and this one is ester. It will not reduce ester, as you can see, as it is same as it is, but it is reducing aldehyde into alcohol, here also aldehyde into OH. So I hope you have understood very clearly, right, this one. Now next is what from primary aliphatic amines. So when we talk about the primary aliphatic amines, at that time, as you can see, the reagent is here is what, NaOH, NaNO2 plus HCl. Okay, so in very when this reaction will be carried out at a very low temperature, as you can see. So it will form, when it will be carried out in a very low temperature, it will form what, NaCl and HNO2. Okay, now next what we are doing, we are using here RNH2, and again here HNO2. At that time what will happen, this hydrogen and this oxygen will combine and it will form like this, as you can see here, right? And again when we will further hydrolyze this, it will form Rn2 positive and Cl negative. Okay, now next is, as you can see, in the place, in case of this, here also again NaNO2 plus HCl, when we are using in presence of NaHNO2, that time again it will form what, Rn2 positive plus Cl negative. This is called what, deazotization, right? So now next, as you can see, when you are using this RNH2 in presence of HNO2 or H2O, it will form ROH. This is the major product, and byproduct will be either this R-OH or alkene or RCl. This may be the byproduct, but the major product will be alcohol, as you can see here, right? Now next is some of the example is given here, as you can see. Some of the example, in place of NH2 it will come, since here in place of NH2 it will come OH here. Okay, and here again in place of NH2, first of all it will change into N2Cl, and after that OH. Okay, so since what we can see here, carbocations are formed, right? Then if carbocation is forming, we know that there will be a rearrangement, right? So here also, since carbocation is forming, that's why there is a rearrangement. Now next is hydrolyzation, hydroxylization. Okay, so here this is also called syn hydrolyzation. Okay, hydroxylization using KMnO4 or NaOH or OSO4 or H2O2. So these are two types. One is anti-syn hydroxylation, or the another one is anti-hydroxylation. So when we are using syn hydroxylation, here we are using here KMnO4 or either O2 OSO4 or H2O2 or NaOH. Okay, but again when we are saying about the anti-hydroxylation, at that time here we are using a reagent as you can see, CF3CO3H. Okay, and next is MCPBA or HCO3H and CS3CO3H, right? So these are the some of the reagents we are using at that time. So one by one we will see this. Very easy, it is very easy. As you can see, there is a carbon-carbon double bond is there, right? So it will break in presence of KMnO4 or NaOH. This bond will break, this pi bond will break, and this pi bond will break, and it will form like this, either above the plane, as you can see this is above the plane. Okay, so either it both side, if both side alcohol will come, OH group will come both in the both side. So if OH group is coming, then OH group, if one is above the plane, the next one will also be in the above the plane. Okay, and if the both if one is in the below the plane, then that next one will also be in the below the plane. As you can see, both are in the above the plane, right? So how it is happening, as you can see from here, you can clearly see that what is happening here when we are using here KMnO4 or NaOH or KMnO4. So at that time what is happening, MnO4, here this bond is shifting here, and this one is coming here, and this will go here, right? So at that time what it will form, two bond like this. So it will form the product, it will form the intermediate like this, as you can see here. intermediate will form like this, and which will be further hydrolyzed. When you will hydrolyze this in presence of H2O and OH, so it will form this. Okay, so this was about the hydrolyzation, which is called syn hydroxylation, okay, using KMnO4 or NaOH. Now next is what? Anti hydroxylation using acid per acid. Okay, per acid maybe this and this. Okay, so when you are using per acid, at that time what will happen, this will be the intermediate, and one will be above the plane and another will be below the plane. Okay, or if one is this side, another will be in the opposite side. As you can see, one example it is given here. If it is like this in presence of KMnO4, if this is the product, let me explain you here. If this is the product over, okay, so if we are using here per acid, at that time it will, the product will be, if one OH is above the plane, another will be below the plane. Okay, and if we are using here KMnO4 in presence of OH or H2O, at that time it will form the product which in which the OH will be in the both, if both are both, either both will be in the above the plane or both will be below the plane. Okay, so I hope you have understood this. And for symmetrical alkane, always remember that cis and cis will form meso compound, and cis and trans will form racemic mixture, and trans will form meso, and again trans and cis will form racemization. Okay, so I hope today's lecture you have understood, right? So in the next class we will see further. So till that, thank you.